Good morning, students. Last class we discussed about electrochemical cell. Now today we are going to discuss about the batteries. Electrochemical cell is because of spontaneous redox reaction electricity is produced. Batteries are examples of electrochemical cell. So batteries generate the electricity because of spontaneous redox reaction. So batteries are source of electricity. Batteries are classified into two types: primary battery or primary cell, secondary battery or secondary cell. Primary battery is called non-rechargeable battery. Secondary battery is called rechargeable battery. Primary battery is called primary cell. Example is dry cell. Then where we use the dry cell? The cell which we will use in the transistors, wall clocks, remotes. Those cells are called primary cell. This is one primary cell. Here, this one is a zinc vessel. Inside, graphite rod will be there. This one is a graphite rod. Graphite rod is act as a cathode. Cathode means electrochemical cell plus charge. So this graphite rod plus positive end. It is act as a cathode. This zinc vessel. This is a zinc vessel which is act as a anode. Negative end. Now here this is graphite. This vessel is called zinc vessel. Graphite is act as a cathode plus this zinc vessel is act as a anode minus. Then electricity is generated. Here redox reaction is oxidation reaction will be there, reduction reaction will be there. Oxidation takes place at anode, reduction takes place at cathode. Here graphite is act as a cathode, zinc is act as an anode. At anode, oxidation reaction means losing of electron. Here anode is a zinc. At zinc reaction is Zn is converted into Zn plus 2 by releasing of 2 electrons. So this is the oxidation. Zn is converted into Zn plus 2 by releasing of electron oxidation. At cathode, reduction, gaining of these 2 electron, reduction. Now, gaining of these 2 electron, reduction takes place at cathode, at graphite rod, represented with plus sign. Now, this is the cathode. Reaction is 2MnO2 plus 2NH4 plus 2 electron, which is released at anode, 2 electron, gives rise to 2MnOOH plus 2NH3. This is cathode reaction. Inside structure is here in between anode and cathode. In between anode and cathode, electrolyte is ammonium chloride, zinc chloride, MnO2. This is the electrolyte. This is on paste. Ammonium chloride, zinc chloride, MnO2 is act as an electrolyte. In presence of this electrolyte, electrolysis will take place. Here, this is the overall reaction. Here, overall reaction is Zn is converted into Zn plus 2. Zn is converted into Zn plus 2. Here, plus 2 electrons are gained in reduction at cathode. So, 2 electrons at reactant side and product side gets cancelled. The total reaction is Zn 2Mn4 towards the reactant side. Zn 2MnO2 plus 2NH4 gives rise to a product side Zn plus 2 plus 2MnOOH plus 2NH3. This is the overall reaction. Again, next continuation. Here, NH3 is formed here. This NH3 forms a complex with Zn plus 2. This is the complex. Zn NH3 4 charge is plus 2. Now, the potential of this cell is 1.5 volts. 1.5 volts. This is about general points of primary cell. Now, continuation. We can take an alkali in the dry cell also. If we take alkali in a dry cell, the potential value is bit high, that is 1.6 volts. The performance or appearance is same. This is about primary cell. Next example, mercury cell. Primary cell, first example, dry cell is completed. Next one, mercury cell. The mercury cell which we use in wristwatches, calces, that is called button cell. This is a button cell. Here same anode will be there and cathode will be there. Here reaction is at anode. Here this is at anode. Anode is zinc amalgam is act as an anode. Zinc amalgam. Metal with mercury is called amalgam. Here zinc with mercury is called zinc amalgam. It is act as an anode. Cathode is mercury oxide plus carbon paste is act as a cathode. Anode is zinc amalgam. Cathode is mercury oxide plus carbon paste. Electrolyte solution is electrolyte is the paste form. The electrolyte is KOH and ZNO is act as an electrolyte. Then reaction is in a button cell anode cathode zinc amalgam is anode. Oxidation takes place at anode. Zinc react with OH, which is from electrolyte, 2OH, gives rise to ZNO plus H2O plus 2 electron, releasing of electrons. So it is oxidation. At cathode, reduction takes place, gaining of these 2 electrons, reduction at cathode, HGO plus H2O, gaining of these 2 electrons gives Hg plus 2OH minus. Here H2O at reactant side, H2O at product side. 2 electrons at reactant side, 2 electrons at product side. Then overall reaction is Zn, zinc amalgam Zn plus HGO plus here 2OH also gets cancelled. Then gives rise to ZnO Hg. This is overall reaction. Then potential of this mercury cell is 1.35 volts. This value is constant throughout the cell reaction. This value is constant. Why it is constant means here in overall cell reaction there is no ion. Here overall cell reaction ions are there. So it is not constant. Potential is not constant. Here the potential is constant. And one more point. Here MnO2. Take 1 mole of MnO2. Oxygen charge is -2. -2 into 2 -4. Mn is +4. Charge is +4. Here Mn +4 form. Here Mn is here oxygen -2. OH -1. -2 -1 -2 -1 -3. Then Mn charge is +3. So here in overall reaction Mn +4 is converted into Mn +3. Now coming to here there is no ion, so this potential value is constant throughout the cell reaction. This is about the second dry cell. This is about primary cell. Second example, mercury cell. Next we will see secondary battery. Next we will discuss about the secondary battery. Secondary batteries means rechargeable battery. So once the charging is complete, we can recharge that battery. That is called secondary battery. Here secondary batteries two examples are there. One is a lead storage battery, nickel cadmium battery. Lead storage battery, nickel cadmium battery. First we will see lead storage battery, which we will use in automobile, car battery, bike battery, UPS, inverters. Those batteries are lead storage battery. In lead storage battery, anode is lead, cathode is lead oxide. Anode is lead, cathode is lead oxide. Electrolyte solution is 38% sulfuric acid solution is electrolyte solution. Now at anode reaction is Pb plus SO4 minus 2, solid form of Pb, SO4 minus 2 from sulfuric acid electrolyte solution gives rise to PbSO4 plus 2 electrons, releasing of electrons. So it is called oxidation. Next, anode oxidation reaction. So these 2 electrons are gained at cathode. So reaction is at cathode is reduction. Here it is oxidation, here it is reduction. PbO2, cathode is PbO2 plus SO4 minus 2 from electrolyte plus 4H plus gaining of these 2 electrons gives PbSO4 plus 2H2O. This is cathode reaction. Anode reaction, cathode reaction. Oxidation, reduction is there, so it is a redox reaction. Now overall reaction is here 2 electrons gets cancelled. Reactant side 2 electrons, product side 2 electrons gets cancelled. Now Pb, here Pb, next PbO2, all reactant side Pb, next PbO2, here SO4 minus 2, SO4 minus 2. So it is 2SO4 minus 2 plus 4H plus ions, 4H plus ions, 2SO4 minus 2. So it is called 2H2SO4 gives rise to PbSO4 2 moles. Here 2 PbSO4 plus here 2 2H2O plus 2H2O. This is called overall reaction. This overall reaction for while battery is working. So when the battery is a source of electricity, this is the reaction. When it is a source of electricity, it is a reaction. When the charging is get over, we need to charge the battery. Then the reaction becomes reverse. That is, on charging, while discharging, this is the reaction. Discharging means battery is act as a source of electricity. Battery is the generating the electricity. This is the reaction. While charging, reverse reaction will take place. Reverse reaction means product become reactant side, reactant become product side. Now the reaction is products 2PbSO4 plus 2H2O. 2PbSO4 plus 2H2O. Reactant side PbO2 plus 2H2SO4. PbO2 plus 2H2SO4. This is on charging reverse reaction. The potential of this cell is 2.04 volts. This is about lead storage battery. Where we will use the lead storage battery? In automobile industry, in a car battery, as a car battery, bike battery, and UPS. This is about lead storage battery. Next one, nickel cadmium battery. Nickel cadmium battery, anode is a cadmium, cathode is hydroxide nickel. Hydroxy form of nickel is a cathode. Electrolyte is aqueous KOH is act as an electrolyte. Now at anode, oxidation, releasing of electron, cadmium, OH minus ions from aqueous KOH, cadmium to OH minus gives rise to cadmium oxide plus H2O plus 2 electron, releasing of electron, oxidation. These 2 electrons are gained here. Cathode, hydroxy form of nickel plus 2 electrons gives nickel hydroxide plus 2 OH minus. Now this is the oxidation, this is the reduction. Overall reaction is here 2 OH minus gets cancelled. Now cadmium here 2 nickel hydroxide plus 2 electrons gets cancelled. So this is the reactant side. Overall reaction, reactant side cadmium hydroxy form of nickel, cadmium hydroxy form of nickel. Next product side, cadmium oxide, next hydroxy form of nickel, OH2 plus H2O. This is reaction, overall reaction of nickel cadmium battery. Here cell potential value of this nickel cadmium battery is 1.3 volts. This is very expensive compared to the lead storage battery. Here the lifetime of this nickel cadmium battery is more than lead storage battery. This is about the secondary battery. We discussed about lead storage battery and a nickel cadmium battery. Next we will see about the fuel cells. Here fuel we can use here either methane, ethane, butane, oxygen or hydrogen. Here we use hydrogen oxygen. So this fuel cell is hydrogen oxygen fuel cell. So see the construction of fuel cell here. Hydrogen passing from here left side where anode is there. Porous anode, porous electrode. This electrode is nickel electrode. Both the electrodes, anode, cathode, both the electrodes are nickel electrodes. Here this is porous electrode. Here we are passing hydrogen gas through the porous electrode. This side we are passing oxygen gas through the porous electrode. Here electrolytic solution is aqueous KOH solution. Now we are using the fuel hydrogen towards the anode, oxygen towards the cathode. Because of these fuels, chemical energy is converted into electrical energy. So it is a fuel cell. Here hydrogen, oxygen acts like a fuel. Now here the cell reaction, anode, electrodes are nickel electrode, both the electrodes are nickel electrode. Anode, at anode reaction is we are passing hydrogen react with OH minus from KOH, aqueous KOH, react with hydrogen, react with aqueous KOH, OH gives H2O by releasing of electrons. This equation into 2, then the reaction is 2H2 plus 4OH minus gives rise to 4H2O, 4 electrons. Now at cathode, this is the cathode. we are passing oxygen gas towards the cathode. Now oxygen gas is passing through the porous electrode of cathode. Here react with electrolyte present in the cell. Oxygen react with water H2O. Aqueous KOH react with water by gaining of 4 electrons gives 4 OH minus. This is cathode reaction. Overall reaction is here 2 into H2, then it is 2H2. 2 into 2OH, then it is 4OH minus. 4OH minus, 4OH minus gets cancelled. Next, 2 into 2H2O, 4H2O, 4H2O here 2H2O, 4H2O minus 2H2O here we will get the, here 4H2O, 2H2O, we will get the 2H2O product sign. Next, 2 into 2, 4 electrons, here 4 electrons, here 4 electrons gets cancelled. Then overall reaction is 2H2, 2 into H2, 2H2, here O2, here this 2H2O is 4H2O minus 2H2O, we will get the 2H2O towards the product side. Then this is the overall reaction. Overall reaction is 2H2 plus O2 gives rise to 2H2O. So here in this reaction, water will be produced. Water will be produced. Then we will see the importance of this fuel cell. This fuel cell is used in spacecraft, especially Apollo space program. This fuel cell is used in Apollo space program, where here water is produced. This water is used by the astronauts. Next important point is the efficiency of this fuel cell is 70%. Generally, here we are producing the electricity by using the fuels, by using hydrogen and oxygen. We are producing the electricity. Here efficiency of this one is 70%. Thermal plants, say energy is converted into electrical energy, then thermal plants, efficiency is 40%. Here efficiency is equal to, we know the formula, work done by heat absorbed or released. Efficiency is equal to work done by heat absorbed or released into 100. Here work done is delta G, spontaneous redox reaction, delta G naught by heat delta H naught into 100. Here we already studied electrochemical cell, delta G is equal to minus NFE delta H into 100. This is a calculation of efficiency. Now this is about the fuel cell. Now fuels we can use methane, ethane, butane, hydrogen and oxygen. Here we use hydrogen and oxygen, so it is a hydrogen oxygen fuel cell. Then next continuation of last topic about the electrochemical cell, that is about the corrosion, that you need to practice. That is the homework. Then next class we will discuss about the numericals and Nernst equation. Thank you very much.